This is the first part of Chapter 5. We're going to be going over chemical quantities and reactions altogether. So today I'm going to have two topics for you: moles, grams, and Avogadro's number, and second, physical and chemical changes. We start off by looking at three samples of elements. We have a lead bar, a bunch of silver bars, and a pile of copper. Now the masses that were weighed out were all the atomic masses of each element, weighed out in grams. So you can look them up on the periodic table. Question is, how many atoms of each element are in the samples? Well, nobody knew. But they made an assumption that if they weighed out the atomic mass of any element, they would have the same number of atoms in each sample. So they called that number a mole. Didn't know what it meant. In fact, the mole was actually short for a word that meant a heap or a pile of things. So we can say then that if you weigh out 207.2 grams of lead, you have 1 mole of lead atoms. And if you weigh out 107.9 grams of silver, you have 1 mole of silver atoms. Or if you weigh out 63.55 grams of copper, then you would have 1 mole of copper atoms. Now again, in the beginning, nobody knew how many atoms that was, and they really didn't care, because they could still do a lot with these numbers. Now, when we weigh out the atomic mass in grams, we're going to call that the molar mass, because that's the mass of 1 mole. So if we go back at this, look at that same diagram now, we have the lead, the silver, and the copper, and we said we have 1 mole of atoms of each of them. This is how many atoms we would have of each one, exactly the same number, and this is a phenomenal number. Phenomenally huge, 6.02 times 10 to the 23rd atoms. That would be 602,000 billion, a number that's just inconceivable. Well, that number of atoms was not determined by the following fellow, Avogadro, but he started off the ball with this. I should say he started off by doing some experiments which led to this number. And so that number itself is called 1 mole, and it's also called Avogadro's number. And the symbol is a capital N with a sub-capital A. So a 1 mole simply means that number of things. So a mole is very similar to the word dozen. Just like a dozen means 12, a mole means 6.02 times 10 to the 23rd. So if we have a mole of atoms, now we know how many atoms we're looking at. Really not going to do anything with that number, but we could if we wanted to count atoms. Just like we don't do anything usually with the word dozen. We buy eggs by the dozen, or we could buy dozens of eggs, but we don't think about buying individual eggs. We could always figure out how many eggs we have in a certain number of dozens, but it's just easier to keep it all in dozens. So it's going to be easier for us just to keep atoms in terms of moles rather than individual atoms. Now here's another example. Here are 2 elements, sulfur and iron, and down below the symbols are their atomic masses. So now these would be the molar masses of each one. So 1 mole of sulfur weighs 32.1 grams, and 1 mole of iron weighs 55.8 grams. So that tells us that iron atoms are heavier than sulfur atoms. How many atoms do we have? You got it, Avogadro's number, 6.02 times 10 to the 23rd of each. Now what if I took a sample of copper atoms like I had before, 63.5 grams of copper, and that's 1 mole of copper atoms, and that's Avogadro's number. And what if I took my sample and I cut it in half? So if I divided my mass by 2, I'd be dividing everything else by 2. And so this would be half a mole of copper, or 3.01 times 10 to the 23rd copper atoms. We're going to be dealing mostly with moles and grams. We're not going to bother with using Avogadro's number. So here's an example here. A gold coin contains 80.0 grams of pure gold. How many moles of gold atoms is this? So we'll be given grams of gold and we're looking for moles. So what do we need to know about these two? We have to be able to link grams to moles. And so for that we just need the atomic mass. So the atomic mass, which we're now going to call the molar mass, of gold is 197 grams per mole. So you can just tell by looking at the numbers, 80 grams is less than half of 197 grams. So our answer is going to be less than a half a mole. Now we go to set up the solution. We start off with our given information. And then I'm going to take my molar mass and view it as a conversion factor. and I'm going to have my 1 mole on top and my 197 grams down below. And then I would, as I normally would do, I would cancel out the gold, grams of gold that is, and then I would see my answer. And as I predicted, it's less than half a mole. So it's not too hard to answer these questions. Well, here's another question. A ring contains 0.0500 moles of gold. How many grams of gold are in the ring? So now we're given moles and we're looking for grams. So we still need to use the molar mass as we did before. But in this case, we're going to take our given information and we're going to set up our solution to it. And how we're going to put our molar mass in here. So now we're going to have the grams on top and the moles in the denominator. And again, you can see that the moles would cancel out and we get grams for an answer. And that has the same number of significant figures as I started with. I started with 3 and I ended with 3. Let's take a look at some compounds now, because just as we can have moles of elements and moles of atoms, we can have moles of compounds. So here are 3 compounds. We have some sodium chloride. In the middle, we have some potassium. You recognize K, potassium. We have some potassium dichromate. And then over here, we have some sucrose, or table sugar. So if I want to figure out how much 1 mole of these compounds weigh, it's going to be pretty simple. I'm going to look up the atomic masses of each one and then just add them up. So let's see what we get for sodium chloride. So the atomic mass of sodium is 23. The atomic mass of chlorine is 35.5. And I want to keep a number in the tens place anyway when I do this. I just add them up, and this is now the molar mass of sodium chloride. So 1 mole of sodium chloride weighs 58.5 grams. Now what about in a formula when we have subscripts? Well, we're going to wind up multiplying the atomic mass by its individual subscript and then adding them together. So for potassium dichromate, I would get this. So potassium is 39.1 times 2, chromium 52.0 times 2, and oxygen is 7 times 16, and we get pretty big mass. So 1 mole of potassium dichromate weighs 224.2 grams. And now we're on to the sucrose. So I have to look up the atomic masses of carbon, hydrogen, and oxygen. You don't have to memorize the atomic masses at all. You'll get used to using them. So for that one, for the carbon, it's going to be 12 times 12. The hydrogen, 22 times 1. And the oxygen, 11 times 16. And I get 342.0 grams per mole. So finding the molar mass of a compound is something everybody should be able to do. So here are 3 of them for you to try. So why don't you pause the video right now, write down the formulas, and see if you can come up with the molar masses. And when you're ready to see the answers, just continue on with the video. Right, so here's the answer for the first one. For sodium hydroxide, we have 23.0, that's the sodium, 16.0, that's the oxygen, and 1.0, that's the hydrogen, and we get 40 grams per mole. For the whoops, didn't know I had that going. For the glucose, I have 6 times 12, 12 times 1, and 6 times 16 for the oxygen. I get 180. And then for the last one here, I want you to notice this now. We have the subscript 2 outside of the parentheses. So this 2 is multiplying everything in it. So it's going to be 2 times the nitrogen and 8 times the hydrogen. And that's exactly what we're multiplying here. 2 and there's the 8. And we get a total of 68.1. So in general, you want to keep atomic masses to the tens place. That works out pretty well. And this is something that everybody can do. Now, let's answer some questions using the molar mass of compounds. A student needs 0.122 moles of sodium hydroxide for an experiment. How many grams should be weighed out? So our question is in 0.122 moles of sodium hydroxide, and we want grams. So I need the molar mass of sodium hydroxide. So it's 23 for the sodium, 16 for the oxygen, and 1 for the hydrogen. Now I know I just said we needed numbers in the tens place, but for these it would all be zeros. So I'm going to let it go for now. So bear with me on that one. Now for the setup, I'm going to start with my moles of sodium hydroxide. And I want to take then my molar mass and set that up here. Since I'm starting with moles, I need moles down in the denominator, and that's exactly what I get. And of course I cancel out my units, multiply, and there's my answer. Now here's a similar question. It's about water though. A water bottle contains 522 grams of water. How many moles of water are in the bottle? So we're given grams of water and we're looking for moles. So I need the molar mass of water. So the molar mass of water would be 2 times the hydrogen, which is 2 times 1, plus 16, so we get 18 grams per mole. And I'm going to do my setup. Here's my grams of water. Now I need to have grams down here in the denominator, moles up top. See how that'll cancel that out. And I get my answer up, 29.0 moles of water. Now here are some for you to try. So again, you want to pause the video and write these problems down, and then come on back and check out the answers. Okay, here are the solutions. For the first one, we need to get the molar mass of sodium chloride. So if I did that, that would be 58.5 grams per mole. And you notice then the moles will cancel, and I get 29.3 grams for an answer. In the second one, I need to have the molar mass of sodium oxide. So that's going to be 2 times the sodium plus the oxygen. That's 62 grams per mole. And again, the moles will cancel out again. I get 109 grams. Now for down here, we're looking for the number of moles. So I still need the molar mass, but when I set it up, I'm going to have the grams in the denominator. So I have to figure out how much does 1 mole of aluminum hydroxide weigh. So that's going to be 1 aluminum plus 3 times the oxygen plus 3 times the hydrogen. And I get 78 grams for an answer. So see, now the grams will cancel, and I get 0.321 moles. 3 significant figures balancing off the 3 here. And then for the last one, I need the molar mass of SO2, and that's 64.1 grams per mole. And there go the grams, and I get 1.95 moles for an answer. So how did you do? Hope you did pretty well.